Hello, good morning, students. I am your Jagadish Kumar Bandar, physics teacher. Today I am going to explain vector second session. Already we completed in previous session what is the physical quantities, scalars and vectors basic introduction. Today we are going to discuss about extension of vectors. Let us see. Today we are going to discuss representation of vectors. Representation of vectors. And the next one, angle between the vectors. And unit vectors. And some problems based on basics of the vectors. Today we will see these 4 points in this session. My dear student, first I am going to explain representation of vectors. Let us see. What is the representation of vectors? How to represent the vectors we will see. Suppose I am going to consider a car is moving with a speed or with a velocity. I am going to consider a car is moving with a velocity. We know that velocity is a vector quantity. Velocity is a vector quantity. We know that. So a car is moving with a velocity 15 meters per second. So a car is moving with a velocity 15 meters per second. I am going to consider that is the car A. 15 meters per second towards east. Towards east. How to represent? How to represent? Let us see. So I need to take one arrow to represent the velocity vector. I am going to assume 1 centimeter length is equal to 5 meters per second. This is my assumption. Just we are going to assume. Assume that 1 centimeter length is equal to 5 meters per second. So at the time car is moving with 15 meters per second means what is the length of the arrow I require? So I require 15 centimeter. See, 15 meters per second speed is given. 1 centimeter I consider 5 meters per second. That is our assumption. To represent 15 meters per second, how much length of the arrow I require? 3 centimeters. Why? Because 1 centimeter 5 meters per second means 3 centimeters 15 meters per second. That means the length should be 15 centimeters I require. To represent 15 meters per second, how much length I require? 3 centimeters length I require. 3 centimeters length I require. So that's why to represent 15 meters per second, how much length I require? 3 centimeters. That means this is the 3 centimeters length. That is the magnitude of velocity of the car A. Velocity of the car A. And how to represent direction towards east? That arrowhead we need to mention pointing towards the east direction. It is known as arrowhead or simply tip of the arrow. The tip of the arrow or arrowhead we need to point towards the east direction. Now this is the representation of a car is moving with a velocity 15 meters per second towards east. And I'm going to give one more example for better understanding. I'm going to consider car B is moving with a velocity 15 meters per second. Let us see. If suppose I'm going to consider car B is moving with 15 meters per second or 20 meters per second, anything you are going to consider towards towards northeast, northeast, then outer represent. We know that the directions, this is the east direction, west direction, north direction, south direction. Generally, we are going to represent directions like this. It seems to be a Cartesian coordinate. Positive x-axis represents east direction, negative x-axis represents west direction, positive y-axis represents north direction, negative y-axis represents south direction. Towards the negative y-axis, south direction from the origin. Suppose, how to write 20 meters per second towards northeast? We know that this is the northeast, this is the northeast, let us see. This is the northeast. That means, if previously I assumed 1 centimeter is equal to 5 meters per second, the same assumption I am going to consider here also. So we are going to assume, assume that 1 centimeter is equal to 5 meters per second. We are going to assume, to represent the 20 meters per second, what is the length of the arrow I required? 1 centimeter 5 meters per second means for 20 meters per second I require 4 centimeters. That's why the length is 4 centimeters. The length is 4 centimeters. But the arrowhead we need to represent in which direction? Northeast direction. Northeast direction. If I'm going to mention the arrowhead or tip like this, the arrowhead pointed towards the east. So this is not our required vector to represent the car B velocity. So car B velocity, how to represent? That is the situation. So we need to draw the arrowhead or tip pointing towards the northeast. That means I need to draw, this is the northeast direction. So take the northeast direction like this. Now the length 1 centimeter 5 meters per second means for 20 meters per second, what is the length of the velocity vector I require to represent the velocity vector with a graphical representation of arrow. Here I am going to consider for 1 centimeter 5 meters per second means 20 meters per second. For 20 meters per second, for 1 centimeter 5 meters per second, I assume that for 20 meters per second, what is the length of the arrow I require? 4 centimeters. That 4 centimeters length represents magnitude of the velocity 20 meters per second. 20 meters per second. Then this arrowhead or tip pointing towards the northeast direction. Northeast direction. So this is the representation of velocity of a car B or velocity vector of a car B, which is moving with 20 meters per second towards the northeast direction. So this is the way we need to represent any vectors. So finally, what we are going to understand, to represent any vector, we are going to using one arrow. Now, the length of the arrow represents magnitude of the vector. The length of the arrow represents magnitude of the vector. The tip or arrowhead represents or pointed towards direction. Tip or arrowhead pointed towards the direction. So finally, we are going to take in the length of the arrow with the selected scale. Previously I assumed 1 centimeter is equal to 5 meters per second. Like that, we need to selected scales. I need to draw the length of the arrow with a selected scale. We need to assume 1 centimeter or 1 meter, like that. We need to assume the velocity. So 1 centimeter is equal to 5 meters per second. I assume the previous problem. In that way, if suppose any car moving with 15 meters per second means I need to draw the length 1 centimeter 5 meters per second. I assume that. Then to represent 15 meters per second magnitude, I required 3 centimeters length of the arrow. And the tip or arrowhead pointed towards the direction of the vector, given vector. If it is a velocity means that is the velocity vector. If it is a force means that is the force vector. Acceleration means acceleration vector. Any vector, this is the concept to represent a vector. Right. Note down. So if I am going to consider any vector rotated, then what will happen? If suppose I am going to consider this is the horizontal line or x-axis, I am going to imagine one vector like this. This is the length represent magnitude of the vector. Any vector, it may be force, velocity, acceleration, any vector, momentum. So here what happened? The length of the arrow represent magnitude of the vector. The arrow pointed towards the direction. Suppose this vector making some angle theta with the horizontal or x-axis. Horizontal or x-axis. This is the vector A bar. If I'm going to assume that the vector is rotated through an angle theta dash. If I am going to rotate it, the vector A bar through an angle theta dash, the length of the magnitude won't be changed here. So what is the length of the A bar vector? Here also length of the new vector is also same. Why I am going to use the word new vector? Even though the same vector I am going to rotate it, its direction is changed. Its direction is changed. So what is the direction of this vector? Just imagine. Suppose this vector direction, if suppose I am going to consider this is the perpendicular, this is the perpendicular. Suppose this is the 45 degrees, I am going to assume it means what is this vector direction? Northeast. Northeast. Suppose I am going to extending like this and I am going to assume this is also 45 degrees. This is also 45 degrees from here. So I am going to rotate it. This vector, suppose 90 degrees I rotated. Theta dash I consider 90 degrees. Theta dash I am going to consider 90 degrees. That means I rotated here 90 degrees means this is 45 already we know that. This is perpendicular. Then this angle is 45 we know that. 45 we know that. Then what about the remaining angle? Why? Because totally it rotated 90 degrees means the remaining angle 45 degrees. 45 degrees. If you want if you want this arrow, you will increase the angle somewhat for clarity. So what happened here? This is the 90. Already this is 45 I said. This is 90 means the remaining angle 45. Why? Because this is perpendicular I consider. Now theta dash is 90 degrees I consider. What is the meaning of that? This vector A bar rotated 90 degrees. 90 degrees. That means it is 45 means the remaining angle should be 45 degrees. Then this is 45 means obviously this is also 45 only. It is 45 means obviously this is also 45 only. Don't consider here small, here larger. In my diagram, that is the rough diagram. But mathematically it is 45 means this is also 45. If these two are 45 means what about this direction? This is northeast. Northeast. This is the west, this is the north. So then what happened? This is what? Northeast. This is the northwest direction. Northwest direction. Why? Because this is the north direction, this is the west direction, exactly middle. 45, 45 I consider no, exactly middle. Then this is the northwest direction. That means this vector means what? Not only magnitude plus direction. That combination only vector. Of course, it should obey the law of vector addition also. No doubt at all. So your vector means what? Magnitude and direction. The same vector rotated an angle 90 degrees here. Magnitude is constant. It won't change. Magnitude does not change because of rotation. Magnitude does not change because of rotation. But direction may change. If any one changes, the vector we said we are going to consider changes. If any one, magnitude or direction, or both also of course, at least any one of these two changes means we are going to consider vector changes. Vector definitely will change, should be changed. That's why this vector a bar means this vector not a bar. This is the another vector. Even though length of the vector is same but directed towards the northwest, that a bar vector directed towards the northeast. Here what happened? Even though magnitude same, direction is different. Northwest direction now the new vector is representing. That's why I used the word new vector, this one. So from this what we are going to understand, if I am going to rotate an angle theta, any vector, its magnitude remains unchanged. That means constant. But direction, there is a chance to change. So if direction changes, we call it as vector changed. Vector changed. That's why rotation of a vector, we call it as, suppose I am going to rotate in 360 degrees, then same vector. If I am going to rotate 360 degrees, then a bar and the final vector both will coincide, no? That's why same vector only. Other than 360 degrees, if I am going to rotate, what will happen? Vector will change. That is because of not changing the magnitude. Why? Because magnitude is not changing. Vector changes because of its direction changes after rotating an angle theta. That's why we call it as, if a vector rotated an angle theta, what will happen? Its direction changes because of, we confirmed that vector is changed. That's why I'm going to give another name b bar. So what is the final conclusion? If any vector rotated through an angle theta, then vector change. We call it as vector also change. This is because of direction changes. Note down, students. Next one, parallel sliding of vector. Suppose I am going to consider this is the x-axis or horizontal line, and I am going to imagine a vector here, a bar. So I am going to parallel sliding. Parallel sliding means the vector slides at any position. From this position, this vector can slide to any position without changing the angle. Then we call it as parallel sliding. Suppose here, what is the angle I am going to consider? 30 degrees. Suppose this vector I am going to sliding from this position to this position. this position to this position. Observe. This position to this position, the same vector without changing the angle. At the time what happened? Without changing the angle I am sliding means here what is the direction I am going to consider? The same direction present here. The same direction present here. If angle is same means direction is also same. If angle is same after sliding, then what happened? Then if angle is same after sliding, then direction remains unchanged. Means direction is not changing. So while sliding a vector from one position to another position, direction, that means angle not changed, means direction is also not changing. So here what happened? Vector means magnitude plus direction. If I am going to sliding a bar vector from one position to this position, length of the vector won't be changed while sliding. And one more condition, I sliding, parallel sliding, I said. Parallel sliding means what? Without changing angle, I need to slide a vector. In such a condition, if angle is same means at both positions, then direction remains unchanged, I said. Then what happened? When I am going to do the parallel sliding, magnitude won't be changed, means the length of the vector does not change. Length of the vector does not change. And direction also not change. Why? Because same angle I said. Parallel sliding means same angle. Direction also not change. That means magnitude not change, direction not change, means vector value also not possible to change. That means parallel sliding does not change the value of the vector. Parallel sliding again will give the same vector only, a bar only. You can slide the vector from one position to another position. Suppose I want to slide this vector from this position to this position. Slide it, no problem. This vector I need to slide from this position to here. Suppose this is also making some angle 30 means just leave it. No problem. Slide it, no problem. So in that way you can slide to anywhere without changing angle. Right. Not down. Right. The next one, angle between the two vectors. How to take the angle between the two vectors? What are the conditions we require? First thing, if I am going to consider two vectors in this manner, this is the vector A bar and this is the vector B bar. To take the angle between the two vectors, the first condition is one vector tile meets the another vector tile, that is tile to tile meeting, or tiles together at one place, or one vector head should meet other vector head. That is the first condition to take the angle between the two vectors. So this is the vector A bar, this is the vector B bar. That means How to take the angle between the two vectors? First condition, both vectors tiles meet together at one point. Both vectors tiles meet together at one point, or both the tips of the vector or heads of the vector, both arrowhead, head means arrowhead, both arrowhead of the vector vectors, that means both vectors arrowhead. So that means we need to understand both vectors arrowhead meet together at one point. Both vectors arrowhead meet together at one point. That is, we need to check. Second point, we have the two angles here. Here one angle, theta 1 consider. Here another angle, theta 2 consider. Which is the angle between the two vectors? Smaller angle between the two vectors is the angle between the vectors. When compared to theta 1, theta 2 is larger, theta 1 is smaller. So theta 1 is smaller than theta 2. Smaller angle is the angle between the two vectors. So that is the second point. Smaller angle is the angle between the two vectors. Two vectors. Here also, first point is what? Both vectors tiles meet together at one point, or both vectors arrowhead meet together at one point. So here what is happening? Both tiles are meet at one point. Both the tiles of two vectors meet together at this point. That is the first condition. Second condition, smaller angle is the angle between the two vectors. Here theta 1, here theta 2. This is the smaller angle between the two vectors. And compared to theta 2, this is the smaller angle. That's why theta 1 is the angle between the two vectors. Here, what is the angle between the two vectors? Theta 1. Theta 1 is the angle. Angle where? Between the two vectors. Between the two vectors. Similarly, observe here. Not only both vectors tiles meet together at one point, also both vectors arrowhead also meet together at one point. That is also okay. So here vector A arrowhead, vector B arrowhead meet together at one point. That's why this is also first condition satisfied. What is the second condition? Take here angle, here angle is alpha, here angle is beta. Which one is the smaller angle between the A bar and B bar? Alpha. So alpha is the smaller angle and compared to beta. Then what is the angle between the two vectors? Smaller angle is the angle between the two vectors. That's why alpha is the angle between the two vectors. Angle between the two vectors. Note down, students. Pause the video and note down. We are going to solve the problem. Let us see the problems. First problem. Find the angle between find the angle between the following vectors. Between the following vectors. Following given vector pair. Given vector pair. Let us see. I am going to consider this is the one vector and this is the one vector. First one. Here I am going to consider 60 degrees. Here I am going to consider 300 degrees. Which one is the angle between the two vectors? Just do it yourself. The second one, I am going to consider like this. I am going to consider like this. Both arrows meet at this point. This is the 80 degrees and this is the 280 degrees. What is the angle between the two vectors? Here this is the vector A bar, B bar. This is the vector C bar, this is the vector D bar. What is the angle between vector C bar and D bar? What is the angle between vector A bar and B bar? Calculate. Calculate. Pause the video and do it yourself. Here, first condition, both tiles meet together. Vector A bar tile, vector B bar tile meet together at this point. First condition satisfied. Second condition, that smaller angle. That smaller angle is the angle between the two vectors. When compared to 300, 60 is the smaller angle. Therefore, 60 degrees is the angle between the two vectors. Here, what is the angle between the two vectors? So, both heads are meet at this point. Meet together at one point. First condition is satisfied. Next condition, this is the 80 degrees, this is the 280 degrees. Between these two, 80 degrees is the smaller angle between the two vectors. That's why 80 degrees is the angle between the two vectors C bar and D bar. That's all. Second problem. Second problem. Find the angle between the two vectors given below. Let's check it. If I am going to consider this is the one vector and this is the another vector. This is the another vector. This is the another vector. This is the one vector A bar and this is the another vector B bar. And here angle is given, suppose 60 degrees. Now what is the angle between the two vectors? Video, pause it and do it now. Just pause the video and do it yourself. Okay, right. Here 60 degrees is given. This is the vector A bar and this is the vector B bar. And here, what is the first condition to decide the angle between the two vectors? Both vectors tiles meet together at one point, or both vectors head arrows meet together at one point. But that first point is failed here. So first I need to make that first point is valid here. How? We know that parallel sliding of vector does not change its value. Already we discussed it. So that's why what happened. I am going to sliding this vector A bar from here to here without changing its angle. What is the angle is given? 60 degrees. Just extend the line and I am going to extending. See, I am going to sliding this vector from here to here. Just to slide it. I said parallel sliding. Parallel sliding. Parallel sliding of a vector. What is the meaning of that? Without changing magnitude, that is means length of the arrow. Without changing direction, that means without changing the angle. Here what is the angle? 60 degrees. So this vector making 60 degrees with this line. Parallel sliding means what? The same vector A bar without changing length of the vector and without changing angle. What is the here? 60 degrees. And here also 60 degrees. What is the meaning of that? Parallel sliding. length of the vector not changing. What is the length? The same length consider here. What is the angle here? The same angle I consider here. Why? Because this vector making 60 degrees with this line. With the same line, the sliding vector also making 60 degrees only. Then we call it as parallel sliding. Why? Because angle is not changing, direction is not changing, length is not changing, vector is not changing. It is also a bar. In this situation, here this is the tile of vector b bar, and again this is the tile of vector a bar, and both the tiles are meet together. Both tiles are meet together at one point. Then first condition is satisfied. What is our first condition? Both the tiles meet, both vector tiles meet together at one point. That condition is satisfied after parallel sliding. And what is the angle between the two vectors now? Check it. This is one angle. What is this angle now? This is one angle, and this is the another angle between vectors b bar and a bar. This is one angle. This is another angle. This is the another angle. What is this angle? This is 60 degrees. This is the straight line. And now the sum of these two angles, if I don't know this is x, means x plus 60 is equal to 180. We call it as linear pair generally. Then what is x? 180 transpose to other side minus 60. Then x value I am going to get 120 degrees. That means the sum of these two angles is 180 means, why? Because form a linear pair. This is the straight line. So this is 60 means the other angle obviously 120 degrees. The other angle obviously 120 degrees. If it is 120 degrees means what is the remaining angle? Why? Because the total angle is nothing but complete angle, no? So this angle I know that. This angle I know that 120. Then what is the remaining angle? 240 degrees. Then when compared to these two angles, 120 is the smaller. So that's why 120 degrees is the angle between given two vectors. Is the angle between given two vectors. Two vectors a bar and b bar. Right. So it is simply we can do with a trick also. If it is a bar, it is b bar, your angle is given 60 degrees, correct? Then one tile and one head, one vector tile meets another vector head. At the time, suppose angle between the two vectors simply 180 minus what is the angle given here? 120 degrees. That is the angle between the two vectors. That is the simple trick without doing all those things. This is the complete explanation, but this is the trick. So, if I am going to ask one more question, this is the c bar vector and this is the d bar vector. C bar and d bar. But c bar tile, d bar head meet together and is given here angle is 30 degrees suppose. Then what is the angle between the c bar and d bar vector? Without doing all those things, what is our simple trick? 180 minus the given angle here, 30. How much? 180 minus 30, 150 degrees. That is the angle between c bar and d bar vectors. That is the angle between c bar and d bar vector. So, better solve in such a manner. Okay, right. This is the way we need to calculate angle between the two vectors. And here remember, parallel sliding of vector does not change its value. That is, we are going to using to calculate the angle between the two vectors when one vector tile meets the other vector head. Next one, unit vector. What is the unit vector? What is the unit vector. If suppose I am going to consider any vector, generally what is the use of unit vector means it is used to represent the directions. It is used to represent the directions. So the vector whose magnitude is 1 unit and it represents a particular direction and it represents a particular direction. Generally is called unit vector. Unit vector. Generally, we are going to represent unit vectors with cap or hats. If I am going to consider vector, unit vector A, unit vector A, I am going to consider unit vector A. So how to represent A cap? It is read as A cap or A hat. You can read. And any vector A bar, how to represent? It is a product of, vector means what? It consists both magnitude and direction. Already we discussed unit vector is used to represent direction. Why? Because it's magnitude 1. That's why. It's magnitude 1. That's why we are going to using unit vectors to represent direction. So that's why any vector consists magnitude and direction. Suppose A bar is a vector. It is a product of its magnitude and its direction. What is the modulus of A bar? It is the magnitude of vector A bar. What is A cap? A cap represents A bar direction. Then how to write the A bar vector? Magnitude, direction. This is the magnitude. This is the direction. So magnitude, direction, the product always give the vector. Vector. That's why how to define the A cap now? A cap is nothing but A bar vector transpose the magnitude A bar side. Mod A bar. Then how to define the A cap or unit vector? Vector divided by its magnitude. Any vector divided by its magnitude will give the unit vector. Why? Because vector means what? It is a product of its magnitude and direction, I said. A bar means what? Magnitude and direction. If I am going to divide with the magnitude, what remains? Direction. That is only A cap, that is only unit vector. That is only unit vector. That's why how to define any unit vector? Its magnitude by its vector by magnitude. Any unit vector, how to define? Its vector by its magnitude. Suppose B vector, unit vector, to calculate what we need to do? B vector by B vector magnitude will give the unit vector in the direction of B bar vector. That is the direction of B bar vector. This is the explanation of unit vectors. And I am going to give some examples for unit vectors. Let us see now. Suppose I am going to consider the Cartesian coordinates. X-axis, y-axis, take it, x-axis and y-axis. So, unit vector along the positive x-axis, we are going to represent it with I cap. Unit vector along negative x-axis, we are going to represent it with minus I cap. Unit vector along the positive y-axis represented with plus j cap. Unit vector along the negative y-axis represented by minus j cap. J cap. So I cap means what? Unit vector along the positive x-axis. J cap means what? Unit vector along the positive y-axis. Similarly, what is minus I cap? Unit vector along the negative x-axis. What is minus j cap? Unit vector along the minus y direction. Similarly, I am going to consider z-axis. Not possible to draw the z-axis into the space. That's why I am going to consider this is the z-axis now. So from the origin outward, that is outward normal from the origin, outward normal or outward line or outward normal from the origin, we call it a positive z-axis. This is outward line or outward normal from the origin. And this is represented with a symbol like this. If I am going to mention like this, what is the meaning of that? Outward normal. So in this direction, what is the unit vector? Plus k cap. Why? Because positive z-axis. And from the origin, inward normal, we call it as minus z-axis. That is what? Inward normal. From the origin. And it is represented with a into symbol. If I am going to write into symbol, that is from the origin inward line or inward normal. That is, we call it as a negative z-axis, and we are going to represent it with the negative k cap. These are the unit vectors to represent the Cartesian coordinates axis. Not only that one, if I am going to consider east direction, west direction, north direction, south direction. What is the unit vector along the east means I cap. Why? Because east is along the positive x direction. What is the unit vector along the west direction? Minus I cap. Why? Because that is along the negative x direction. What is the unit vector along the north direction? Positive j cap. Why? Because that is along the positive y axis. Similarly, what is the unit vector along the south direction? Minus j cap, because that is along the negative y direction. Similarly, it is called outward normal is called upward. Why? Because if you are going to consider this is the vertical plane. You are writing on your book, that is on a horizontal plane. In a horizontal plane, from the origin, outward normal means what? Upward. Observe yourself. I am going to repeat. This is the vertical plane. You are writing on your book on a horizontal plane. On the horizontal plane, from the origin, outward normal means what? Upward. That's why this outward normal we also called upward. That upward is nothing but positive z-axis only. Then upward represent with k cap, positive k cap. Similarly, on your book, just imagine from the origin, inward normal. From the origin, inward normal means what? Downwards. Take your book. place on a horizontal plane, try to write. Then what will happen? From the origin, inward normal is called downward. Just observe yourself. Downwards. That is nothing but negative z-axis, and it is represented with the minus k cap. That means east means I cap, west means minus I cap, north means j cap, south means minus j cap, upward means k cap, downward means minus k cap. These are the unit vectors to represent the directions. To represent the direction. East direction represented with a unit vector I cap, west direction represented with a unit vector minus I cap, north direction represented with a unit vector j cap, south direction represented with a unit vector minus j cap, upward direction is represented with a unit vector positive k cap, downward direction represented with a unit vector minus k cap. Like that, we are going to using the unit vectors to represent the directions. Note down, students. Pause it and note down. We'll solve some problems. First problem. Find the unit vector. Find the unit vector of find the unit vector of 4i cap plus 3j cap minus 5k cap. We need to calculate unit vector of this given vector. What is the unit vector formula? Consider given vector as a bar. This is the a bar vector. 4i cap plus 3j cap minus 5k cap. This is the given vector. To calculate unit vector, what is the formula? A cap is the unit vector. Then I required a bar vector and its magnitude I required. Already a bar vector I know that. Then how to calculate magnitude? What is the meaning of this vector first of all? 4 units along positive x direction, 3 units along positive y direction. What is the meaning of this one? Let us see. A bar is equal to 4i cap plus 3j cap plus this can be written as 5 into minus k cap. This minus is the actually direction. Minus k cap. That is only we are going to write like this. Minus into plus, minus we are going to write. But actually this is the original notation of this. So what is the original notation of this? This one. 4i cap plus 3j cap plus of minus plus 5 of minus k cap. 4i cap plus 3j cap plus 5 of minus k cap. Both are equivalent only. Here, what is the meaning of that? 4 units along the positive x direction, 3 units along the positive y direction, 5 units along the negative z direction. 5 units along the negative z direction. Negative z direction. Why? Because minus k cap represents negative z direction. That is the meaning. How to calculate this magnitude? Root of I cap coefficient 4 square. I cap represent direction. J cap coefficient 3 square. J cap represent direction. 5 square minus k cap represent direction. Minus k cap represent direction. Then 5 square. Then 4 square is 16. 3 square is 9. 5 square is 25. Then 16 plus 9. 25 plus 25 root 50. This can be written as 25 times 2. So bring the 25 from the root as a 5. 5 root 2. That is the magnitude of A bar. Now how to calculate A bar vector, A cap vector, that is direction of a given vector. A bar, what is A bar here? 4i cap. You can write this one or this one, that is your choice. 4i cap plus 3j cap minus 5k cap by what is its magnitude? 5 root 2. This is the unit vector magnitude. This is the unit vector. We need to calculate. This is not unit vector magnitude. This is the unit vector. This is vector. This is unit vector. This is unit vector. Mod a bar is the magnitude. Denominator magnitude. Numerator a bar vector. So one vector is divided with the scalar. Resultant is a vector only. That's why a cap is a vector. Unit vector. How to calculate unit vector? Given vector I consider a bar and calculate the magnitude of the a bar and substitute the values. We are going to get the unit vector of given vector. Okay, right. One more problem we are going to solve. Suppose there are given two vectors. A bar vector is given. A bar vector is given. Consider 4 I cap plus 3 j cap. And B bar vector is also given. Consider 24 I cap plus 7 j cap. These are the two vectors which given. Then we need to calculate one vector. Find a vector whose magnitude is same as that of B bar vector and parallel to A bar. Observe. That is we need to calculate. Given vectors what? A bar given 4 I cap plus 3 j cap. B bar given 24 I cap plus 7 j cap. Then what we need to calculate? Find a vector whose magnitude is same as that of B bar vector and parallel to A bar. So my new vector I am going to consider C bar. Let required vector I am going to consider required vector is C bar. Let it be. Then how to write a C bar vector? Let required vector be C bar. Let required vector be C bar. I am going to consider let required vector be C bar. I am going to consider. Let required vector be C bar. Then consider C bar. What is the required vector? Required vector magnitude is same as that of B bar. That means C bar vector magnitude is also same as that of B bar vector. That means B bar vector magnitude, C bar vector magnitude should be same, he said. That's why what he said, we need to calculate one vector whose magnitude is same as that of B bar. That means C bar vector magnitude is same as that of B bar vector. Magnitude of the C bar is, why? Because I need to write C bar means what? Its magnitude and its unit vector. This is the situation. According to given problem, what is given? Whose magnitude, that means required vector magnitude is same as that of B bar is said. That means required vector magnitude is C bar. Whose magnitude is same as that of B bar vector is said. That is the meaning. C bar vector means what? Its magnitude, its direction. Product will give the C bar vector. But according to problem, magnitude of the required vector is same as that of B bar. Magnitude of the required vector is C bar, mod C bar, is same as that of the vector B bar. That's why these two magnitudes are equal. That's why in place of mod C bar, I wrote mod B bar. C bar is equal to mod B bar. And he said, and parallel to A bar. So two parallel vector always having same direction. Two parallel vectors always have same direction. That means our required vector is parallel to A bar is said. Our required vector is parallel to A bar. What is the direction of A bar? A cap. What is the direction of A bar? Direction of A bar is A cap. Then what is the direction of C bar vector? C cap. So these A bar vector parallel to required vector. Required vector parallel to A bar vector. Both the same meaning only. So required vector is parallel to A bar means required vector I consider C bar. That's why required vector direction and A vector direction should be same. Should be same. That's why in place of C cap, I am going to writing A cap. So the required vector has magnitude of the B bar and parallel to A bar. Magnitude of the B bar means magnitude of the required vector and magnitude of the B bar vector both are same. That's why in place of mod C bar I wrote mod B bar. And what is C cap? Direction of the vector C. But this vector is parallel to A bar. So that's why what is the direction of A bar vector? A cap. What is the direction of C bar vector? C cap. Both are parallel. If both vectors are parallel, they have the same direction. That means A bar vector direction, C bar vector direction, both are same region, both are parallel. That's why in place of C cap, I replaced A cap. Now, from the given vector, what is the magnitude of the B bar calculate? What is the magnitude of the B bar calculate? B bar vector is given 24 I cap plus 7 J cap. Then how to calculate magnitude of the B bar? Square root of 24 square plus 7 square. That is the magnitude calculation formula. 24 square 576 plus 7 square 49. You are going to get root of 625. Finally, we are going to get 25. That is the magnitude of the B bar. How to calculate A cap? How to calculate A cap? A cap is equal to A bar by mod A bar. What is A bar? Given vector A bar 4 I cap plus 3j cap by mod A bar. What is the how to calculate mod A bar? So root of mod A bar, magnitude of A bar, root of A bar vector. So 4 square 16 plus 3 square 9. 4 square 16, 3 square 9. Root 16 plus 9, root 25. Root 25. That is 4 I cap plus 3 j cap. This is what root 25. Root 25 means 5. This is the A cap. Now substitute those values. C bar is equal to what is the magnitude of B bar? 25 into what is the A cap? 4 I cap plus 3 j cap by 5. That is the A cap. 5 get cancelled in 25 5 times. Then C bar is equal to 5 into 4 I cap plus 3 j cap. Distribute the 5 for both the terms by opening the bracket. 5 4 just 20 I cap plus 5 3 just 15 j cap. This is the required new vector. This is the required new vector. I think it is clear. One more problem I will give. Try to solve, my dear student. Just pause it and note down. Right. Suppose A bar I am going to consider 3i cap plus 4j cap, and B bar I am going to consider 1i cap plus 2j cap. Find a vector whose magnitude is same as that of B bar vector and parallel to A bar. Parallel to A bar. How to calculate? Let a required vector, consider let a required vector be C bar. Then how to write C bar? He said C bar required vector consists same magnitude as B bar and parallel to A bar. Parallel to A bar means C bar vector, required vector is parallel to A bar. That means C bar vector direction, A bar vector direction same. So that's why in place of generally C bar means mod C bar C cap. But in the problem, magnitude of the C bar, required vector magnitude, and magnitude of the B bar, both the same is set. And A bar vector and C bar vector, both are parallel is set. C bar means required vector, that is parallel to A bar is set. That means A bar direction, C bar direction, both are same. That's why in place of C bar direction, I'm going to take in A bar direction. That is, in place of C cap, I'm going to write in A cap. Now calculate the magnitude of B bar. What is the magnitude of B bar from here? Magnitude of B bar is equal to square root of 1 cap plus 2j cap. That is 1 square plus 2 square. That is root of 1 square is 1, 2 square is 4. That is root 5. That is the magnitude of B bar. How to calculate A cap? How to calculate A cap? Calculate A cap. A cap means A bar by mod A bar. What is A bar? A bar is 3i cap plus 4j cap. What is mod A bar? Root of 3i cap means 3 square, 4i cap, 4j cap means 4 square. That is the modulus of A bar. So 3i cap plus 4j cap by root of 4 square 9, 3 square 9, 3 square 9, not 4 square, 3 square 9 plus 4 square 16, 9 plus 16, 3 square 9 plus 4 square 16, 9 plus 16, 25, root 25 value 5. This is what A cap. Now substitute. Mod B bar means what? Root 5. A cap means what? This is only A cap. Substitute here. 3i cap plus 4j cap by 5. So here root 5 get cancelled in 5, root 5 times. Then what is our C bar vector? 3i cap plus 4j cap by root 5. That means C bar vector is what? 3i cap plus 4j cap. Root 5 get cancelled in 5, root 5 times. So in denominator, root 5 remains. This is the C bar vector. Note down, my dear students. Pause it and note down. My dear student, we will meet in next section, continuation of vectors only. Thank you, my dear students.